Hello 108 students, Mr. McCue here. Welcome to section 10.2. We're going to work with exponential functions. We're going to focus on page 1 of these class notes. I just want to bring up here that we're comfortable working with functions such as y equals x squared. Notice that the x is down in the base, and we know this produces a parabola from our previous discussions from chapter 9. We're going to explore the possibility that f of x could be used to represent y, and now the base is going to be a number. We'll use the letter a to represent that, and the x is going to go up into the exponent. Okay, so that's what the basic definition of an exponential function is. We're now going to deal with the x being up into the exponent. A couple notes here: the base needs to be greater than 0, and the base cannot be equal to 1. What you want to take in mind here is that if a would be 1 and I took it to a variable, x could be 2, or you could have a be 1 taken to the 4. These all equal each other because 1 raised to any exponent always equals 1. And so there's no need to really consider that in these discussions here. That would produce a horizontal line with y equal 1. Okay, so we don't focus on that. So what we're going to do here is we're going to take an equation here, a fairly simple one, the parent graph. Perhaps you might want to consider it. Going to take f of x equals 2. The base is going to be 2 raised to the x. The exponent is x. Notice in this example, a, the base is greater than 1. I like to consider that a whole number. And f of x, we're going to replace it with y. And we're simply going to go ahead and do an expanded xy table and see what kind of values we can get here. Okay, so I pick a couple here. I want you to follow these details in here so you can study the fact that you pick enough points, you can start to plot the graph and get a feel for it. Notice if I let x equal -3, you are always going to put the value for x, take it and put it into the exponent, and take 2 raised to the -3. Just keep in mind that's the same as saying we don't care for negative exponents. You'd say 1 over 2 to the third, so 2 to the third is 8. So that equals 1/8. Okay, and that's where the 1/8 came from. Input -3, output 1/8. Notice where that's at down here. It's below 1 here. It's getting close to the x-axis. Put a -2 in. 2 raised to the -2 is 1/4, and that would put you about right here. And you can see I'm working a couple of these. If you let x equal -1, the output is 1/2, slowly kind of rising on the y-axis. And then we hit this interesting situation of x equals 0. This is crucial because we're going to find that any base raised to the 0 power equals 1. And so this is called the turning point, or the elbow point is my nickname for it. 0, 1 is right here. This is always going to happen on these graphs. And watch what happens to the rate of increase here now. When I put 1 in, 2 raised to the 1 gives you the ordered pair 1, 2. 2 in for x, 2 squared is 4. Now the exponential function really starts to take off. Let x equal 3, 2 cubed, or 2 to the third equals 8, and you can see you're all the way up there real quick. Notice how quickly between the going from each unit of x, how quickly the rise is. Okay, that's the power of an exponent. It starts off easy, it hits the turning point, and then lo and behold it goes quickly, accelerates. Imagine if this was 4. 4 squared would give you 16. I'd quickly be going up there. Okay, so I just want you to notice that this is called a growth graph because you're going from left to right. The graph is slowly increasing up the y-axis. Think of this as growth. And now we're going to go ahead and study a case of the base being a fraction. So in example 2, I let, instead of saying f of x, I happen to choose g of x. The book likes to use it every once in a while. don't let that bother you. It still represents y. The base now is a fraction. It's greater than 0 but less than 1. Pick 1/2. Pick something kind of easy. The exponent is x. Okay. And so just to watch this a little bit, in my notes I put 0.5 in for a half. You might want to just use that 1/2. You might be more comfortable with 1/2. Take it to the x power. And when you work some of the arithmetic here, just be careful. You realize that that would be 1/2 raised to the -3. I'm just going to do one of these real quick. 1/2 raised to the -3. We have a shortcut rule that allows us to, if you see a negative exponent, you write the reciprocal inside the parentheses. So 1/2 is 2 over 1. Take it to a +3, and there's your result of 2 cubed is 8. Okay, so make sure you follow those details. Notice what happens here. Going from left to right, we start at -3 on our graph. We come up here and hit 8. We start up high. As we work our way down, you put -2 in for x. The output is 4. We quickly are decreasing. Put -1 in. The output is +2. And then look what happens when we let x equals 0. At anything, any base raised to the 0 power always equals 1. And so therefore we've hit the elbow point or the turning point again. You want to find these first when you're graphing these. Sometimes this elbow point can be shifted, but in this case it's at the same spot. Now when x equals 1, you have 1/2 raised to the first power gives you a 1/2, and notice how quickly we start to go 1/2, 1/4, 1/8. Now if you turn around there and put a 4 in here, if x would be 4, 1/2 raised to the 4th would give you 1/16, and we'd be about right here. Here's our 4, and I want you to see that both on these examples we will never hit the x-axis. The y value will never approach 0 but get closer and closer. And that was the same thing up here on the top graph. You will never hit the x-axis, but the y value will get smaller and smaller as you go down, but it'll never hit. And so think about that here. Every time you put a negative value in for x up in this example, you're going to get 1/16. You put 5 in there, you're going to get 1/25. And so as the denominator gets bigger, that entire fraction keeps getting smaller and smaller and smaller. I find that very interesting. You can never actually touch the x-axis where y equals 0. Okay, now this graph, when you look at it, you start off with a big value on the y, you quickly descend. This is called a decay graph. And so you want to look at these from left to right. You can see the slope is going down. When you look at the one here, when a, the coefficient, when the base was a whole number greater than 1, it went up. If it was a fraction, it goes down. Okay, these are observations to get us started here. That should wrap up page 1 here. When I see you next, we'll be moving on to page 2. Okay, bye.